to RoboBoat. I'm having an amazing time. Is everybody else? Yeah. So I'm gonna try and go over Team Minion is the name of the team that I was the team lead for. So I'm gonna try and go over the architecture behind Team Minion and what we did to keep our students engaged, keep one another motivated and moving throughout. Because RobotX is every 2 years for competition, unlike RoboBoat, which is every single year. This is a lot harder to retain people in a situation like that. So thank you for coming. So my name is Dutch Holland. I was one of the co-team leads for Team Minion at Maritime RobotX Challenge 2022, and we did come in first place. Not by much, but it was the first place. So again, thank you for coming. I was born and raised in Florida, and currently I am working on my master's degree in mechanical engineering. My undergraduate is in mechanical engineering, and I also am an intern for RoboNation working on product development.
Yay, RoboNation!
Okay, so the first thing I'd really like to talk about is our weekly overview of what happens for the team. So obviously all of us are students, or at least most of us are students, and a few of us are faculty advisors. So students, we have to really work around their schedule. It's quite difficult, especially if you're an undergraduate student. Master students, they go to class once or twice, and that's the end of it. Whereas undergraduates, which is most of us here, I would imagine, we all have to go to class every day, all day long. So we have a weekly team meeting, and that's where everybody comes together, software, hardware, electrical, so on and so forth. We come together and we give the entire team an update on what it is that we did last week, and then the direction that we're headed in next week. So for an example, as one of the hardware leads, if I was working on a thruster configuration, I would say, hey, this is the CAD that I've come up with, these are the parts that I've ordered, and the direction that I'm heading is building from those parts once they get into the lab. Or if I'm an electrical guy and I'm working on a PCB, then I would explain where I am in that. And if I need help reviewing those parts or pieces, then those that are more experienced will be there and be able to meet with me. Following that exact meeting, which is typically held on a Friday afternoon because most students don't have class after that, somewhere between 2 and 4 o'clock is when we would hold our meetings. It depends on each one, so we send out a wind meet to figure out when everybody can actually show up. So right after our weekly meetings, we do what we call workday. So normally the meeting's about 30 minutes. We try to tend to stay between 20 and 30 minutes. We don't want people to get bored or feel like they're wasting their time. After that is workday. Workday is where everybody is together for at least 2 hours. That's what we try to schedule for. This semester, it starts at 3 o'clock and goes till 5 o'clock. So that's a chance for the electrical guys, the hardware guys, the software guys, and everybody else involved to be in the same room at the same time working on stuff. So if you're an electrical person and you have a design that needs to get in a box, and your hardware guy is there and he is or she is holding you back and saying, wait, you have to make that box bigger, but you know that discussion can go down in person, looking at the hardware and make that decision. Software people are there to talk to hardware people about thruster configurations or the way things are mounted and why, so that way you can prepare for it and code. So it's a really great opportunity for the entire team at one time. It's also really good time to bring new students. They get to see the project. They get to meet everybody at one time because you're going to go through in a circle and talk about who you are, what you're doing, all at one time. Then we have sub-team weekly meetings. They happen when that sub-team has determined that they can actually meet. So for an example, our hardware team meets typically on Fridays from 5 to 6 o'clock because we're already still there and we were too busy to meet from 3 to 5. So that would be us going over CAD together, really just the tight group. Then moving forward, or I'll give you another example. Software always meets online. We used to do in person, but ever since we've got Zoom and Discord, and we're more used to doing that, it works a lot better because you can share your screen to one another. Most software people are using 2 screens, so they're Googling one thing and diagnosing your code with you on another screen. It tends to work really well, and what will happen is we'll have a Zoom meeting or a Discord chat that's got 12 or 13 people working on it. And if you're in Zoom, you can do breakout rooms really easily. They go and work on things together without any problems with keeping the flow of the meeting going. And then we try to test monthly. This is very important because one of the most difficult things is getting new members to show up and stay. You can get them to show up one time, but it's hard to get them to show up consistently, especially if they don't get to see the robot doing things, and that's really what they want to be a part of. So what we try to do is not only from our side of hardware, software, and electrical, but also retaining new team members. We try to test once a month. Now, that's really difficult, and we are only like 8 minutes from the water. So I understand it's difficult. Sometimes it's easier to just throw it in a pool and go for it. Or sometimes it's easier to just say, hey, we are all going to be in the lab. So our monthly testing looks like a Saturday, we get in the lab at 8 in the morning, we're on the water by 9. We have students that are trained on our chase boat, and they'll go out and deploy all of the buoys that we want to test on. And then we have software people setting up what we call ground station, and then we have some other people working on some side projects, like for RobotX, for example, there is a UAV and there's also an underwater vessel sometimes. So those can be tested all at the same time. It allows everybody's morale to come up because they're excited about seeing their project work. I know that I personally get a little bit, we don't see the boat on the water for a couple of months because it's like, are we really making progress? It's a lot of fun when you get out on the water, you got a bunch of buoys out there, and it actually follows a path, or it detects a dock, or something else great happens. Maybe you get your thrusters working for the first time in the new configuration, anything like that. And then 2 key points about your meetings that you need to remember is keep them consistent, always in the same time, in the same place. If you change these things throughout the semesters, new students will get confused about when they are, where they are, how to get involved in them. So make sure that you try and keep those things as consistent as possible. That would include your weekly or your monthly testing. And one more point on testing. So if it is about to be, so like for this semester, if you all came to competition, you're here and you're doing your best, that's awesome. For RobotX, for Team Minion, our competition was last semester, and we tested every single weekend before the event actually happened, before we had to ship our boat. And we actually had it where we were testing 2 times in a week. It's very tiring, it wears people out, but it is an absolute necessary thing to do when you're getting close to competition. Because the bugs that you're having now, you would have had a month and a half ago, and you can get further faster. Part of this is trying to win the competition, but the major part of it is learning. And being out on the water testing your system is where you learn the absolute most. So remember, try to test as much as you can. That's what this is about. You have a question? Yeah, go ahead.
Tests should have like a goal.
Yes.
Because if you do like tests for no reason, you're just wasting your time.
Absolutely.
Because what happened to us, we were testing, but we weren't testing anything. We were just putting it in the water. We were just driving around. That's not the point.
That is a good point. I'm glad you brought that up. So he said that you should have a goal to your testing. That is absolutely true. So as a team lead, I would work with my other team lead, like my software leads, and say, what are you ready to test? What aren't you ready to test? That way we could be prepared, and there would be a test plan, check mark or checklist that I'm going through as the day goes on, and I'm making sure, hey, that's checked, let's move on. Somebody's stuck, can we do something else while they try to figure that out? So give yourself a goal for that test. If you don't have anything to test, don't test. That's more chance for you to break your hardware, to be honest with you. It's not good to go out on the water if you're not doing something. It is risky. So yeah, for us, that's a big thing. And weather, don't forget to check your weather, right? 15-mile-an-hour winds, we cut it off. Doesn't matter if our boat can operate, it's nope, it doesn't matter. Could you go to the next slide, please? So this is the architecture that I'd like to go through for the leadership. So as you can see at the top, it says faculty advisors. Those, of course, should be in charge of the project and help make all the decisions of where it should go and how money should be spent. We are here to learn, we don't know everything. Directly following that is team leads. That is multiple team leads. For my case, there was 2 team leads, myself and Erasmo Andreetta. He was the other co-team lead. Because it's very difficult to manage a project that has not only but a boat, but a submarine and UAV, right? Now you have a submarine sub-team, electrical team for that, a hardware team for that, and a software team for that. And the same thing is true for your UAV. So that's not up here, but you can look at it in the exact same way. So the team leads, whoever's leading the overall project, directly communicates every day with your faculty advisors, gives you the direction that you need to be able to go in and advise. And then your major team leads deal with your hardware leads and your software leads and your electrical leads. Sometimes it's not exactly ideal to put a bunch of leads in there. So let's say you have a team of 6. Well, I've got a lot more than 6 bullets up there, right? So, and it could be a lot more than that, especially if you have multiple platforms dealing with one, right? Just used to have UAV involved there. So if you're a team of 5 or 6, don't delegate a bunch of different team leads, because then you have a bunch of leadership that's not getting anything done, right? So be careful with that. But so for ours, we had a hardware lead, but we did not have an electrical lead. We didn't have enough people for that. And we had a software lead. The hardware lead and the electrical lead were the same person and dealt with both of those problems at the same time. It's a little bit more difficult on that person. However, if they are versed well enough, they can handle it. And then under those, you have all the hardware members, or the software members, or of course the electrical members. That is the architecture that the team used for RobotX 2022 competition project. That is the same architecture that we have been using since 2024, and we try to implement this in all of the other teams that are within RARE, which is Embry-Riddle Robotics Association at Embry-Riddle. So RoboBoat, that's the way they should be running here, and I think that this is pretty good. There are some flaws with it. Like I said, if you have a limited number of team members, it's a bit more difficult to do it. So I think that's everything that I have for you guys. I've got a couple of backup slides to show some pictures. Does anybody have any questions about some of the things I covered? Or input, because I'm learning too, so if you see something that you think I should say it, go ahead. Yeah, good question. So there is one work day, everybody shows up. That work day is for if you're testing your UAV, well not testing, but everybody's in the lab working. Let's say that you have a hardware team. They pick their time and they need different. So hardware for us, we meet on Wednesday afternoons, or excuse me, Friday afternoons after the work day is over. Typically what happens is if you get enough students that are involved in the work day, your meeting will end, right? Your meeting starts at 2:30, work day starts at 3, right after that meeting. If it ends early, the work day starts early, and then that trickles into other team meetings sometimes, but it also allows for students to just stick around, right? The lab's open until 2 a.m. at our place. Sometimes we're there a little later, even though we shouldn't be. So yeah, a lot of students will end up staying really, really late on that work day. We designate 2 hours because sometimes for my particular team, we have PhD students that are on it. They have other important things to do. So the designated 2 hours gets it to where if you go to talk to the person you need who you don't see every day right now and gives you that time. Question. Go ahead.
Yeah. Do you have any advice for seeking out like a faculty mentor?
That's a bit difficult. So she's asking if I have any advice for seeking out a faculty mentor. The advice that I would give first off is whatever you're doing, you should look for a faculty member that teaches a class about what you're doing. That's a good first start. The second start is go to an office hour, talk to them about what it is you want to do, and see if they're interested in that time. And if there's not, obviously you move on from there. There is sometimes, so at my school, there's a thing called Office of Undergraduate Research. So for undergraduate students, you go and you can be put directly in contact with anybody doing any type of research on campus. It's a database and a place to go to be able to meet people who work with these people every day. So Office of Undergraduate Research, you walk in and say, hey, I'm working on microgravity. Okay, go see Dr. G. Oh, I'm working on autonomous systems. Who should I talk to? Go see Dr. Eric Paul. They already know who it is. They have a system. They have to have it. So maybe your school has something like that. And if not, word of mouth works too. Yeah, go ahead.
How do you handle recruitment? How does it happen that people end up in your project? So how this process looks like in your team?
Yeah, that's a really good question. So he's asking about how do I handle recruitment. That's a good point of business. So recruiting is on every team member. Do not forget that. If you're a team lead, you need to remind your team members to try and bring new people. The best time to bring a new person is if you're going to test. The next best time to bring a person is, if you could actually go back a couple slides. Is your weekly work day. That gives them a chance to see all the different things, projects that are happening in that room at the same time and say, that thing is the most interesting to me. And then whoever the team lead or the sub-team lead is for that particular project, you say, hey, these are these two people, please, figure out a way to put them in. But again, it is important for whoever is on the team to do recruitment. So we have it under Embry-Riddle. Every semester we have a couple of different events. One of them is PivaCon, which is happening right now, and that's where you build robots out of random things. And you push them out of a ring like sumo wrestlers. So that's a big recruitment event. We have activities fair that happens once a semester. That's another really big recruitment event. But I would like you to know that in my particular case, recruiting from that is very difficult. The other way that I, as a team lead, recruited was I knew my professors that taught me very well. I connected with them as much as I could every semester, whoever the new one was. And then I would go back and say, hey, I'm looking for higher level students because I was in the robotics program. I had robotics teachers. Do you have any higher level students that would be interested in this? And can I give a speech or a little quick talk, if you will, in front of your class this semester about my project and try to get them involved? That worked really well. I turned most of my students in that way. And the other way is try to get your friends as involved. Right? Every semester you have new classmates, new people that you're working on projects with, new people that you sit next to in class. Sometimes it's a little intimidating to speak with new people, but if you just tell them, people like to be talking most of the time, tell them about your project, see if they're involved in something. And then the most important thing is you have to remind them that if you're on a team like this, you look the best when it comes to a resume. Right? At the end of the day, we're all trying to get jobs. They need to understand that they're going to benefit. Everybody here at this competition has a way better chance of getting their foot in the door at a company because they're here doing this now. You have done engineering at a very high level at least one time, whereas everybody else that's not takes classes and that's the end of it, right? So remind them what they're getting at.
How inclusive are you in this process? Do you have any selection process when you people show up. Choose people.
So he's asking about the selection process. For Embry-Riddle, we do not actually have that many engineers on campus. It's a lot less than half the population of the school. Most of them are aerospace. It's mainly mechanical engineers that actually work on our robotics projects. Although there are electrical and software, but it's mainly mechanical engineers. And so recruiting, it's just whoever is willing to put in time and effort. That's as simple as it is. I am not inclusive or exclusive, right? If you want to come, come. If you want to come to Embry-Riddle next semester, you're more than welcome to join the team the day you get there.
Okay, thank you.
Yeah.
How do you go about training new members?
Yeah, good question. Would you
I was just going to comment about functional organizations like
Yeah, so Mary wanted to add that there are professional clubs on campus like SWE, and there's a couple other ones.
Hispanic engineers and Black engineers.
Yes, Hispanic engineers and Black engineers. Those are really good places to go and meet your students who are just trying to be involved, but you may not actually see in class. What was your question? One more time.
How do you go about training new members?
Yeah, good question. So how do you go about training new members? That's a really hard thing to do, and it is a major time sink. It takes a lot of effort. I have always tried to give my availability to that student, and whatever they're willing to work on, if I know how to work on it, I will show them what I know to some degree, and then at some point you have to let people go and try on their own. So, but that's a little bit tricky. Each student is a little bit different. Some people want their hand to be held for quite some time before they go off on their own and figure things out. Whereas other students, they want you to tell them what to do, and then they'll go and figure it out themselves quite quickly. So you kind of got to gauge the student that you're dealing with, and you've got to be prepared to talk a lot and not I don't want to say dumb things down, but bring it down a level, because as an engineering student, you don't realize how much engineering lingo you're throwing at somebody who doesn't understand it for the first or second semester. So you gotta come back to whatever level they may be on, if you're involved in a level to keep them interested, involved, and understand. Any other questions?
But speaking in high level, not low level. Low level is engineering. High level is broad scheme.
Okay, so Mary says speaking in high level, not low level. So low level is engineering, high level is broad scheme. It's like 30,000.
Yes.
Are there any more questions? Yeah.
When you guys run competitions, so have you guys go over like delegating tasks for like fixing problems or when you like
How do you
actually
go?
run competition?
How do you go about designating who does what tasks and fixing problems at
Delegation.
the competition?
Yeah, so delegating is sometimes difficult, especially at the competition. So first off, you're going to have your software leads and hopefully your hardware leads at competition. If there's a problem, that person should know the most about that problem. So I would look at, for example, my software lead, Charles Montragolian, and say, Charles, this is an issue. You guys have this bug in this code, it's not working. I need you and whoever else you think can do that. Now, if I was Charles, I'd look at my next best coder and say, look, I know you might be working on something that's important, but this is critical enough. This is going to hold us back. So I need you to stop what you're doing, and you and I are going to work on this from that point forward. The other thing is delegating regular tasks. So it seems like a simple thing you get a vote in a while, but it's not. It's actually not. There's quite a bit of a process where you need to chase somebody down, figure out who's going to take that person to get you on the list, get you in the water, right? So you should put somebody in charge. Typically what I did was I put whoever was my RC person, or a remote control operator or safety pilot, whatever you'd like to call it, I put them in charge of that process. You need to figure out how to get us on the schedule. Talk to me, I'll tell you when I want us on the schedule. You figure out how to get us on the schedule, get us on the course, and get us done. Because typically, RC operators, sometimes they're doing other things, but most of the time I try to delegate that one person as doing that. And then if I have a problem, like I said, I delegate somebody I know is going to be the best at that. So as a team lead, you need to understand your team. Know who they are. Don't just let them exist in the lab. Know their strengths and know their weaknesses. You don't want to put somebody who has a weakness on something on that same course.
is if you have an experience in any projects like this one, like RoboBoat, do you try to be involved in another competitions at the same time? Is it like different students are just assigned to that competition, or they are assigned to various competitions?
Good question. So what he's asking is, if you have multiple different competition aspects within your organization, does everybody work on all the projects, or is it one set? For my particular school, it's kind of a conglomerate of everybody. However, there are kind of teams that people are, I'd much rather work on RoboBoat than RobotX because for whatever reason it is. Maybe they like the tasks that RoboBoat will do. However, for RoboBoat and RobotX, if you have those two teams at your school, if you can share at least your software members, it's really easy to do once you figure out how to detect a problem. It's really easy to hand that node over, that last node, and say, look, this works. Let's modify it, build it to meet your requirements, and then you're not building.
No, you're supposed to go to trial.
So, yeah, we try to share numbers as much as we can.
Yeah, go to Charlie. I'll take care of the
It's their
dive.
project,
Dive's
it's their
here.
baby, they don't want to go over and work on it.
Or I guess we're
Everybody is
driving.
individual.
Who's diving?
So you got the guy, any more questions? Guy from Carter.
You can talk a little bit knowledge transfer and passing on data and stuff.
Yeah, I can talk knowledge transfer. Knowledge transfer is, again, another really difficult thing. So as a team lead, I will be around 2 more years after being a team lead. So the team lead that's in charge now, if they have questions, I'm there to answer them. And I try to be available, or our team tries to be available, if that person has to leave. The other thing is we have a SharePoint, we have Google Docs, we have a lot of documentation online. If there's a new process that's made, we get somebody, whoever it is that made that process, to document it to the best of their ability. And then leave that, so if you don't know how to operate a battery charger on your first day, you can go on OneNote, and there is a way to teach you how to do that. If you don't know how to turn on the boat, you can go on OneNote, and there's a way to tell you how to do that. And if it's changed, make sure you change it within, right? Because you own those living documents.
Any other questions?
All right, well, thank you all so much for coming and seeing my TED Talk. I really appreciate it. And good luck to everybody at the competition.